Okay, so hello students, this is Dr. Dong. So today will be our last lecture on new content, and in this lecture we're going to focus on disk management and file systems. So let's first look at the physical structure of a hard drive. So in a hard drive we have an ARM assembly. This is like the controller. So and then we have say different, we say each of them we call a platter. So we have different levels of platters and like disks. And okay, and within each, so within each so platter, so for a certain area with for a certain circle with, by using the same radius, we call it cylinder. Okay, this is very important. We call it cylinder, and within different cylinders, we cut it into different small parts, like over here, and we call them sectors. So sectors are pretty much like the pages or frames that we talked previously. So we basically divide this large hard drive space into certain units of minimum size, let's say 2 KB or 4 KB. And then so here with the arm, so the arm can just go inside and go outside. So to basically the the objective is to move the read and write head to the cylinder that contains the file or content that we want to read. So so here then you can say that in order for us, say now if for example you issue a comment saying that you want to read a certain file, and so then from the hard drive, then there are two operations that we must do before you can really read it. The first thing is that we must move the head or move the arm to the desired cylinder, and then within the cylinder we need to rotate so we need to rotate the hard drive so that so the sector that includes the file that you want to read is pointed by the read and write head. So then here so we call we say the time to move the arm to the desired cylinder, we call it seek time. And then we call the time for us to rotate the hard drive in order to move the desired sector to the head, we call it the rotational latency. Okay, so the so there are two things that we need to do. Okay, say move the arm to the desired cylinder, and then rotate the hard drive so that the head points to the desired sector. And we call the first thing the seek time, and we call the second thing the rotation latency. So and the combination of them has a name named the random access time. So here you don't need to remember the definition of them, but instead you just need to remember something named the random access time. So it is the latency for you to find the certain data that you want to read, the certain file that you want to read. So every hard drive comes with such a time, random access time. Pay attention to that. So we want this time to be as low as possible, and this time that depends on a lot of factors. For example, what is it's the transfer rate, how fast does your hard drive can read and write data. And then so for our say say everyday desktop hard drives, not solid state hard drives, but just for hard drives. Okay, so then the seek time on average it is anywhere from 3 milliseconds to 12 milliseconds. And so is the rotational latency. So and here you can say that, okay, so the rotational latency basically heavily depends on the speed how fast can your hard drive rotate. So if it's faster, then the rotational latency would be smaller. So here is that. Okay, so if you got a hard drive with RPM for 4200, RPM means round per second, how many rounds can it rotate in 1 minute. So if you have a hard drive whose rotational speed is 4200 RPM, then the average say rotational latency is around 7 milliseconds. Whereas if you use a hard drive with 5400 RPM, it's around 5.5. So here, I remember that when I bought my first laptop in 2008. Yes, in 2008. So, uh, the I remember that at that time, usually most mainstream hard drives are using this speed, and now they are moving more and more faster to 7200 and then 10,000. So because it can definitely reduce our rotational latency. And the other concept that I want to talk about is say over here. Okay, so regarding the this latency, access latency, you don't have to worry about that. So the other thing that is relatively important about hard drive or about disk management is that, okay, so we definitely use a scheduling algorithm, pretty much like the CPU scheduling and memory management algorithm, to decide, okay, where should we move the ARM to first. So for example, okay, so here we for example, we are giving a sequence of cylinders, okay, which is the number of cylinders that we want to visit. Okay, so how are you going to move your arm in order to save the total amount of time that we spend on moving the arms. So here is an example. Okay, basically usually there are three mainstream disk management algorithms. So the first one is named FCFS, first come first serve. So this is pretty easy. So for example, at the current time, we have the arm pointed to the 53rd cylinder, and now we got a queue, or we got a list of cylinder numbers to be visited. So we're going to move the arm to the first cylinder, which is 98, and then we're going to move to the second one, which is 183, and then so to the third one, which is 37. So here, so if you do this, if you follow this instruction and finish all the sequence, you can find that in total we have our head moved. We move our head in total for 640 cylinders, and that is a lot. That is going to take a lot of time. So to reduce the seek time, people propose an algorithm named shortest seek time first. So the idea is that so giving a sequence of cylinders to be visited, we are going to move the cylinder to the closest one next, and then the second closest one. So this is the idea. So in the beginning, our head is at 53. So within this, given this sequence, we're going to move it to 65, which is the closest one to 53, and then we're going to move it to 67, which is the closest to 65, and then we're going to move it to 37, which is the closest to 67. So here you can see that in total we only end up with 236 cylinder moves, and this is around 1/3 of the seek time compared with the FCFS algorithm before. And the last one is named scan. This one is mostly widely used in modern operating systems. So the idea is that so here to explain it in a better way, I just need to give it a name called elevator algorithm. The thing is that if you want to move your head up, then it can only go up, and then so it will first ignore all the requests that is below it, and then move all the way up, and then make a turn at the top, and move down. So and then next it will also move up. So that's why we call it elevator algorithm, because it works in a similar way as the elevator. So here, let's say we got we have our head at 53, and then say for example in the beginning we want to move to the smaller side. Okay, so we're going to move all the way to the smaller side and move all the way to the larger side. So in total we got, so you can count the number of visits over here, but it's definitely smaller than the previous two. So practically or in practice, this is a very efficient algorithm to help us to reduce the seek time of our hard drive. So that's why it is used mostly. So for the part of hard drive or disk management, so I only ask you to understand what is rotational time and what is seek time, and then also I want you to know that there are three mainstream disk scheduling algorithms, which are FCFS, SSTF, which stands for shortest seek time first, and then scan. So these are everything that I want you to know about hard drives. And then so the next topic is going to be files. So files is say for in Linux system, or also in Windows system, each file is associated with the following attributes, like its name and identifier, and then type. So it's like .exe or .doc or .pdf, and then location. So where it is, so where it is stored on a hard drive, and then size, and then the protection, meaning that who can read it, who can write it, and who can execute it. So also it is associated with the time, date, and user identification, which are used for protection and security. Say for example, usually a file is associated with a time that when it was created, when it was modified the last time, and when it was opened the last time. So this is the common attributes associated with files in every operating system. So if you use Mac, and you can so you can check it from the info window. Okay, so it will give you the details of it. But beside that, so if you use Linux systems, you can, under a certain folder, if you open terminal, you can use the command ls-l, which can tell you L, meaning that list the details. Okay, it will list the details of every folder of every file under your current folder. So for similarly, if you use Windows systems, you can open your CMD, and then use the command dir. Dir will also show everything that is in the current folder. Okay, so the next thing that I want to talk about is the directory structure. So we definitely know files, but how the files are organized with directories. I'm not sure if you have taken the course named that structure, but if you know that structure, definitely you know a structure named tree. So a tree is a structure where each node can have multiple 0 or 1 or 2 multiple children nodes. And then their children node can also have children nodes. Okay? So this is a tree in that structures, a very general tree. But in practice, the files and directories are organized in a tree structure too. So the idea is pretty much like this. So for example, this is our root directory, so the highest level of directory, and then it has three subdirectories, which are spell, bin, and programs, and then each of them points to a set of nodes, which are the files or folders under under this directory. Similar over here, and then we use circles to represent files, and then we use rectangles to represent folders. So for example here, this mail folder includes four subfolders, which are proc, copy, prt, and exp, and then exp only includes one file, which is over here. So the operating system, especially the Linux operating system, use the tree structure to manage the hierarchy of directories. So the reason is that it's really efficient, because so first it is because it allows file sharing. So for example, if we have the same file, the same file can be included in two folders, but we only keep one copy of this file, and this can save us a lot of space on the hard drive. And so also the other thing that why we want to use the tree structure to for the directories is because, okay, say for example, now if you want to remove a file, say for example you want to remove this file from the list directory, so we don't need to physically remove this file, erase this file from the hard drive. We just need to cut this link, say there is no link, and then after we go to the list, after we go to the listed directory, we will find no file under it. But actually this file still exists on the hard drive. We don't have to bother with like erasing the content so on in the specific area that is occupied by this file on the hard drive. So that's the advantage of say using tree structure or graph structure for hard drives and for directories. And the last thing that I want you to know about file system is that before you can access a file system, you have to mount it. Mount is like an operation to tell your operating system that I want to I have a file system at a certain location on my hard drive, so that your operating system is aware that this area of your hard drive can be visited. So yes, and this is everything about our new content today, which includes disk management and file systems. Compared with memory, main memory, and virtual memory, this part is not that important. So that's why I only spent a very short amount of time on it. And also, for you to prepare the final exam, I prepare slides for you. Okay, so when you prepare your final exam, you only need to focus on this one. So the format of the operating system is pretty much like our midterm, but so the content will be like 20% on the content before midterm, and 80% of them would be related to content that we talk about after midterm. Okay, so it's not going to be that hard, given that you guys did an awesome job in the midterm. So I'm pretty confident that you will also be doing well in the final exam. And as I said before, I would expect that perhaps 50% or even more in our class can get at least A minus or so A minus or A, so in the final grade, which is really awesome. And so yes, and this is our my very short video lecture for today. So, and also regarding the final exam time, if you visit the Doodle page, so I would say that a very large a fraction of students vote for the time, which is on December 11th, which is the Friday, from 5:30. I think it's from 5:30 to 7 p.m. Okay, so Yes, so I think it's like 15 out of 17 students vote for this time. Yes, then we will have the final exam at this time. So, yes, and if you need a special arrangement, please let me know. Also, I'm going to send send a canvas announcement today or early tomorrow to let everybody know. Okay, so this is Dr. Zhong, and it has been my pleasure to spend a semester with you. So as I told you before, my objective is to let you know the knowledge about operating systems, but I don't want to take a lot of time from you. I want you to I want you to focus your time on the courses that are more related to your future jobs, like say for example like machine learning, like computer networks, so or databases. They are more important because those courses teach you the skills, and this course teaches you the knowledge. So skills is something which decides if you can do a job or not, while knowledge is something that decides if what kind of potential are you going to have, the breadth, which is the breadth of your knowledge. Um, it is not as important as skills when you are in your job interviews. So hopefully I don't take a lot of time from you, and also hopefully I teach you something. I let you know the design of operating systems. So yes, that will be, if it's that case, that will be wonderful. And so so also I want to thank you for your patience with me and for your effort on this course. And I know that some of you are very busy with your jobs, especially I know that at least 2 or 3 students in our class are working in a hospital or are working in the healthcare industry. They're totally overloaded because of the surge of the COVID cases. I really admire your and thank I really appreciate and admire your efforts. So so stay safe, and so also enjoy the incoming holiday. So thank you, Dr. Dong. Bye.